I start working on my base station, I'm going to disconnect the desoldering gun, which is done by unscrewing these two connectors here, one for the pump, which is the one I'm turning right now, yeah, and one for the heating element, which is this one here, which is something like this. Alright, a connector of this type here. I don't know the exact type number of this connector, but I'll look it up, and if anything I'll mention it below the video. Okay, so there you go. I disconnected my gun from the base unit. So now what I can do is open it up, and basically, yeah, I would say what I would certainly need to do, let's take this off, what I would certainly need to do is unscrew these two screws here and the same ones on the other side for sure. If that's not sufficient, I'll unscrew all the others as well. There you go. Now I should be able to lift this. Oh yeah, here we go. And there you go. This is the inside, the left side of the Duratool, and when you look on the inside, what you see here is the, I don't know if you can see this, guys. Let me give you a little more light. So this is the front panel, all right, with the thermometer and all that. So the readout, in fact, of the desoldering gun, and then probably what this is here, this large chrome box, is probably the power supply, and then this is more than likely the vacuum pump, which is the thing that sucks the molten lead of the PCB, right? So yeah, so this is the vacuum pump, more than likely. And then what have we here? We have the fan right here. Okay, so we have this fan here, which is not a very large one. And then we have a small black mystery box right here, which I have no idea what it is. I might open it up later on and to have a look inside. Okay, so anyway, this is what the Duratool looks like inside. Alright, inside the inlet for the vacuum pump, you know, for the tube coming from the desoldering gun, there is a small particle filter, which I managed to pull out of the socket here, and it's held in place with a seal. more specifically this seal here. It's a reasonably pliable, flexible rubber seal. Nothing completely out of the ordinary or anything. So yeah, I'm going to remove this and replace it with a fresh filter, because this one, I mean, after 3 years is really rather dirty. Okay, so yeah, that's one of the things I'm going to do. And then I loosened the front panel up by releasing these 2 screws here. So by releasing these 2, I can effectively slide off the front panel. Yeah, I can slide off this front panel by pulling it forward and to the side. But to be able to move it to the side, I need to release the wires which are held in a tight kind of loom. As you can tell here, there are several binders, zip ties, that I need to release to be able to move this to the side. And one of the things is that the tube which connects the vacuum connector on the outside, on the front panel, with the vacuum pump on the inside is very, very short. Yeah? And it's held or connected to the connector by a press fit and another zip tie. So yeah, I might have to cut that zip tie and pull temporarily this tube here loose from the front panel connector. Alright, so to my pleasant surprise, there is in fact a fuse built into this 220 volts connector. Alright, so into the AC connector. And this is the actual fuse for the AC input, and it's rated at 3.15 amps. Okay, and to my delight, I noticed that they also included a reserve fuse right here, you see. So in this little cover or holder. Okay, so and it basically, all you need to do is to slide it out of the connector by hooking something just right here behind a center tap, and then give it a little nudge, outward nudge, until the tray sort of slides out like that, and then you can pull it out all the way. Okay, so that's a nice little detail. To release or to be able to move the front panel out of the way, I actually, it turned out I didn't have to cut loose the wiring loom, but what I did have to do was to release this inner bracket, which is mounted on the back side, of the front panel. So down there, in fact, inside there. Alright, so by releasing 2 screws, I managed to slide the on-off button and this little panel out of the front panel, well, this bracket actually, out of the front panel, and which allowed me in turn to cut the zip tie. So the zip tie which connected this vacuum tube to the front connector of the soldering gun. Okay, so now we have a much better view on the insides of the ZD-915. And one of the funny details that I noticed once I was inside the soldering gun base is this. Right in the center of the image is actually the motor for the vacuum pump. And if you look carefully at the inscription on the motor, the inscription on the motor reads the 3rd of July 2017. So that's when the motor was produced. And correct me if I'm mistaken, but it would seem this might just be a Russian brand vacuum pump motor. I'm not sure, but it certainly looks like it. But then again, I could be wrong, of course. In either way, the date, the production date of the motor is the 3rd of July 2017. Alright, so which would mean that the pump is 5 years old, while the desoldering gun, I actually honestly don't remember if I had it for 3 years or 5 years. Interesting. At the back of the fan there was this little sticker here, which I carefully pulled or peeled away. And in fact, inside what you see there is the axle of the fan blade. Okay, you can see it move as I rotate the blade around. Okay, and in fact the motor consists of electromagnets, which you see, just barely see, there inside the hood of the fan blade. Yeah, you can just about see the coils for the fan. Alright, now what I'm going to do is I'm going to spray some industrial degreaser, or well, contact cleaner actually, inside of this, and then I'm going to spray a tiny drop of a silicone oil. Okay, so which is a very, very fine type of oil, yeah, which in my opinion is the appropriate greasing for this type of fan. Alright, so what I'm going to do next is I'm going to have a look, because I can't hold back my curiosity. I really want to find out what is hiding inside this box here. Yeah, and once I know what is inside of it, and since the leads for the fan are going inside that little black box, well, once we've opened it up, I think we can find out what sort of power circuit powers the fan, right? And since we're going to build something to throttle the fan's rotation speed, yeah, we need to figure out how the fan is supplied in power, yeah, and by how much power. Before I can even think about designing an electronic on-off switch for the fan of the desoldering gun and a speed regulation, as it were, I need to do a couple of measurements. First of all, I need to know how much voltage is pumped into the fan. Now, the fan is rated for 24 volts DC, alright? But, you know, that's only what my eyes read, but not what we measure, yeah? So, I found amongst my, in my stash of parts, I found an identical connecting wire as the one which is connected to the fan. There's only, and I pulled out the fan's connector and inserted that instead. Now, the only small annoying detail is that the colors of the polarities are reversed on the little connector that I have. It's annoying, but it'll work. So, first what we're going to do is, I hooked up a multimeter on the output, the voltage or the power source for the fan, and we're going to measure the voltage that normally would go to the fan. Keep in mind though that the voltage we are measuring is without load, so it'll probably be a little bit higher than it would normally be with the fan connected. So yeah, well, here we go. Okay, the meter says 18.1 volts. 18.1 volts. Now we know how much the fan consumes in current, so which is right now 270 milliamps, yeah? And at about 17.1 volts measured as over the fan, yeah, we have enough information to design a sort of an electronic on-off switch or throttle circuit which will be used to run the fan. Alright, so I ran the desoldering gun on and off every 15 seconds for a period of 10 minutes, and really the temperature of the power supply is remains at a stable 34-35 degrees C. So, is this conclusive? Well, yes and no. What this proves to me is that the cooling of the power supply is certainly adequate. Okay, so the output transistors or regulators of the power supply are certainly cooled well enough. So, do I ever have to worry about the desoldering gun base station overheating? Not likely. But in any event, what I'll do is I'll make a little overheating circuit anyhow and build it in just in case. Alright, I made a little circuit on a breadboard with which to control the speed, the rotation speed of the fan, and I had to look for a sort of a happy medium between having the fan run at an idle speed, so causing just a little bit of draft and using a minimum of current. And once the sensor heats up, the fan, provoking the fan to run at a decent speed to cause enough air circulation within the power supply of the base unit of the desoldering gun. And to find, let's say, that happy medium, I resorted to a not very scientific method of clamping a sensor, a temperature sensor, to the NTC resistor that I'm going to use as a sensor in the base unit, and heating it up with my soldering iron. Now, right now, the ambient temperature, as you can tell by the thermometer here, is indicating the temperature is about 18 degrees Celsius, which would be, I think, around about 48 degrees Fahrenheit or something like that. So let's say it's normal room temperature. So I'm going to power up the fan, okay, and then we're going to apply some heat to the NTC, which is the temperature sensor. So here we go. Alright, now the voltage at the fan right now, as you can tell right here, is a little bit less than 8 volts. So I would say around about 7.5 volts, which makes the fan run at a very low speed. Yeah? And if you look at the power supply right now, it consumes around 30 milliamps, which is really low power consumption. Alright, so let me heat up the sensor and then show you the speed increase of the fan. Alright, you'll see the voltage that runs to the fan increase. Yeah, right now it's about 10.5 volts. So the fan is now starting to run full tilt. Right, I can feel the draft all the way up to where I'm sitting. Yeah. So one of the reasons why I picked 7.5 volts starting voltage is I noticed the fan would not run consistently when I fed it less than that. So it starts to run at about 4 volts DC, but it's not consistent, so sometimes it wouldn't switch on consistently. And I noticed that when I feed it about 7.5 volts, it would start up consistently every time. Okay. And we're almost at 60 degrees. Yeah. Now we're at 65 degrees and about 11 volts. 11 volts going to the fan, and now I can feel quite a lot of air current. So In my opinion, this setup will work perfectly inside the base unit. So the only thing I need to do right now is transfer all these components to a little PCB. Okay, and when that is done, I'll show you the result, and we'll build it into the base unit of the desoldering gun. And here you have it, the finished speed regulator for the little fan that will go into the back of the base unit over there. Alright, so it's a quite simple little circuit which I built on an experimental PCB. Okay, so a breadboard PCB actually. So this is the back of it. Alright, and I kept it quite compact, and true to my philosophy, I kept it simple, cheap and effective. Okay, so that anyone, even somebody with very limited understanding of electronics, can build it and use it. Alright, it has basically only one setting with the little blue trimmer you see over there, which is a multi-turn trimmer. Hang on. So by setting the trimmer, you can set the minimum voltage that goes to the fan. Alright, now after doing some experimenting, I noticed that 4 volts is, well, the fan will start running at around 4 volts, but it's not consistently starting at 4 volts. So I decided to set the initial voltage that goes to, at least at room temperature, that goes to the fan is around 7.5 volts, and at that voltage I noticed that it would start every time consistently. Okay, and as the temperature rises, the voltage will rise accordingly, so linearly with the temperature, and it will rise to at around, let's say, 55 degrees Celsius. It will rise by about 5 volts, which will increase the fan speed quite a bit, and the air circulation within the base unit. So this is the last time I can show you the backside of the circuit, because I'm going to cover it up with a special kind of industrial rubber glue, let's say, to protect the circuitry from short circuits and such. You have to keep in mind the polarity of the connector. Okay, don't worry, I'll include the schematic of this speed regulator for the fan in the video. Alright, so there you go. This is it. Now what I'm going to do is I'm going to build the circuit into the base unit, and I'm more than likely I'm going to build it in around about here. Okay, where there's just enough space for it to sit without interfering with anything else inside the base unit. Okay, so next time you'll see the circuit is when I'm done mounting back all the components of the base unit, and then we'll give it a final run in an attempt to diminish even more the noise caused by the fan or mounted at the back, well, inside the back of the base unit. I installed some rubber grommets like this, alright, through which I will pass the screws which hold the fan tight against the frame of the base unit. And of course the immediate result of that is that the fan will stick out about 3 millimeters away from the metal of the case, okay? But that shouldn't pose any problem. Yeah, that should be okay. The main thing is that the grommets, being rubber of course, will dampen any of the vibrations from the caused by the imbalances, no matter how tiny, inside the fan. In case you're wondering what the inner diameter of the holes were where the screws pass through, it's M3, okay? So it's an M3 3 millimeter hole through which the grommet must fit to ultimately let through the screw. Alright? M3. To attach the heat sensor of the fan speed regulator to the heatsink of the power supply, I'm resorting to a little trick, which is I'm going to take an eyelet like this, okay, and I took it apart and I'm going to slide the heat sensor, which is this tiny NTC resistor right here on the tip of my finger, inside there, inside the eyelet contact, alright? And I'm going to pack some heat conductive paste around it, around the NTC resistor, and once I fit the shroud of the eyelet back over the contact, I'm going to pack the back of it with the same industrial glue I use to insulate the print board, alright? And that way the sensor, so the little NTC resistor here, will remain fixed inside the eyelet for good. You know, it won't ever pull away or slide away. So, and that way there should be maximum heat transfer from the heat shrink of the power supply through the copper eyelet into the NTC, and that should give a very good thermal conductivity and contact, exactly what the sensor needs. There you go. The sensor is glued and packed with heat conductive paste and attached to the power supply heatsink. I had to unmount the screw for the temperature sensor, unfortunately, because I had completely forgotten that I needed the same screw to attach the speed controller for the fan as well. And the original screw, which was here, was simply too short to do the job. So I replaced it with a stainless steel 20 millimeter M3 screw. Alright? And I drilled a tiny hole, a 3mm hole, through the print board right here, and that's how I attached it to the power supply. And it's not obstructing any opening. It's far enough from the motor, at least I think it is. It's far enough from the fan as well, and it is, and the sensor is not obstructing anything either. An added bonus, of course, of placing the speed controller on the fan right here is that the fan will help cool the power transistor, which in fact drives the fan itself, which is sort of ironic, but there you go. Okay, so I mounted back everything, including the gun itself, but only to try out the whole thing and to see whether it's not going to blow up in my face or not when I switch it on. And obviously I'm also very curious to see whether it'll be quieter than it used to be. I mean, it should be, right? So that's why we did this. I didn't switch it on yet, but it is connected to the AC power. So what I propose to do is to share with you the first power on after redesigning the power station of my desoldering gun, right? So, well, here we go, I would say. 3, 2, alright. It didn't explode in my face. I didn't see anything spark. The fan is running. And would you believe it, it is a lot quieter. And mind you, the case is still not closed. Okay, so with the case back in place, it should be even quieter. I hope you can hear this, but this is about as loud as the fan gets. Obviously, as the fan is going to run a bit faster, it will produce a little more noise. But right now, it's really quiet. Absolutely quiet. Everything seems to work normally. So, yeah, there you go. So I need to finish a few things, you know, like put a fresh filter in the connector for the desoldering gun, clean it up a little bit, and, well, and that should be it. And then we should give it a final test once this is all done. Just to show you the noise and such that goes on when I pull the trigger on my desoldering gun. Okay, so there you go. This is loud, okay, but you know, it's never longer than a few seconds, so it's tolerable. Alright, so you remember that the stand, the resting stand for my desoldering gun was attached on this side of the case, and in fact it was well, it was a reverse, okay, but I modified the stand somewhat so that I can hook it on the other side of the base unit. Now, my idea was that I would simply reverse the case and then be able to hook the stand on the other side. But this side of the case didn't have these two holes you see right here. So, also, it turns out that the holes at the top of the case, which are used to screw it down onto the base unit, are asymmetrical. So these holes are further apart than these two holes. So unfortunately, for some silly reason, they made it like that, and you can't just simply reverse the case and be done with it. So I ended up drilling two extra holes on the side of the case, which allows me to attach the bracket for the pistol's resting stand on the other side of the base unit. I'll show you the result once I reattached the stand's brackets. Okay, there you go. The side bracket, or the resting bracket for the desoldering gun, is mounted back on the side of the base station. Now, I had to do one more little tweak to this. I couldn't help noticing that when you hook the bracket into, well, when you hook the resting stand back into the bracket, which is located on the side of the base unit, it's rather loose. Yeah, it won't drop off per se, but it is rather loose, and there is a risk that when you take the gun off the stand, that you might pull the resting stand of the gun off or out of its bracket. Now, how did I fix that? Well, quite simply by putting a very strong neodymium magnet between the bracket and the hook of the stand, and that way this will never come loose. It might jiggle a little bit, like as you can tell. Yeah, it might jiggle a little bit, but it will never come loose. Yeah, see? You'd have to really pull very hard to pull it loose. Okay, so yeah, the neodymium magnet certainly solved that problem. I'm sure there are hundreds of better ways to do this, possibly even screwing the hook to the bracket. That could be a solution, of course, but you know, I'm not entirely in favor of drilling holes everywhere in my tools, so I guess the cleanest solution I can come up with right now is using a very strong neodymium magnet. Now, the other thing I had to do to the stand, or the resting stand for the gun, is, well, as some of you might remember earlier in the video, this resting stand here was soldered, or I should say tack welded to the hook on this side. Okay, and obviously that way I could never have used it on this side of the base station, right? So what I did was use an angle grinder and just grinded off the tack welds, and then reposition the guide, or the rail for the desoldering gun, and then attach it with a brass screw. You see right here, okay, with a brass screw to the bracket at precisely the right angle for the desoldering to rest in. Two little details you need to take into account. That is this lip here, this extra lip. For a few minutes I was wondering, why is this lip here on the stand? And it dawned on me when I put the gun back in its cradle like this, yeah, that if this lip wouldn't be here, the whole gun would slide down and would hang like this in the cradle, which obviously is not so good because the tip, the heating tip, doesn't have that much sideways mechanical strength. Okay, the base is much stronger, so that's why the gun rests on this lip here with its base. Okay. The other thing, the other little detail, if that's what you want to call it, is this ring here. There's a ring here. You can move the ring up a few notches or down a few, but I did notice that the best position for it is right where I placed it. Alright, so close to the end of the bed, or the rail into which the desoldering gun fits. Okay, so why? Well, if you put it on its resting stand like this, yeah, if this ring is too close up here, yeah, the gun would sit like this in the resting stand, okay, with the heating tip all exposed, and that would be, well, rather dangerous. You could burn yourself. If, on the other hand, you put the ring, you see here, all the way up front, yeah, the hot side of the desoldering gun is never completely exposed, and so chances to burn yourself are much less. Alright, so normally in the filter of, as I should say, the base filter over there, right there, okay, you'd place one of these little felts to catch some secondary lead dust right at the entrance to the base unit's vacuum pump. Okay, so I thought, this is pretty similar probably to actually car filter material, and I bought myself a cheap car filter, and this foam here is special foam to catch a particulate before it goes into the engine. Now, the paper catches the larger particulate, the smaller particulate, excuse me. The foam catches the larger one. Now, in my opinion, this foam would do just as well in there as this little piece of felt. Okay, so the felt is only 3 millimeters thick. The foam is a lot thicker, but when you compress it, it's about the thickness of the felt. So what I'm going to do is I'm going to slice this foam off, and then cut a little round piece out of it, the size of the original felt. There you go. A perfect round piece. Well, perfect. Maybe not perfectly round, but certainly the same size as the original felt. Okay. So let's reintroduce it on the base unit. Now, on top of the felt went this. This is like, I don't know, sort of a rubber O-ring, I would say. Probably to keep the filter in place. So in it goes, like that, and on top goes this. Come on. Yeah. Like that. Now, a small tip I have is when you need to screw the tube back on onto the base unit. You know, it's a right-handed screw top. You give it a few left-handed twists. Oh, I would say, let's see, 1, 2, 3, 4, 5 twists. And then you place it, come on, you place it on the base unit like that, and then you screw it back on. Like that. Now, why did I do that? Well, if you connect it up to the base unit without giving it those left-handed twists first, it'll just twist up in a right-handed way, and you'll be stuck with a tube which is completely twisted up and in a big knot. Yeah. So that way the vacuum tube won't get knotted. So there you go. The car filter cost me, I'd say, if I remember correctly, the car filter cost me about 15 bucks, which might sound like a lot, but I mean, I cut one filter out of it, you know, and I think I can easily get 100 of these filters out of one piece of foam, you know, and that would cost a lot of money. I mean, 100 of these felt pad filters would cost me at least as much as that car filter, and I think a lot more, in fact. So, in a final analysis, what can I say about my desoldering gun and its station? Well, I've had it for, I was wrong, in fact. I haven't had it for 3 years. This year I will have had it for 5 years, and so far it has served me well. Yeah, it's practical, it's not expensive in use, and now that I improved the fan control, so I built in a fan control. It is a lot more quiet. Yeah, in fact, I don't think you can hear it right now. It's just a faint buzz. Okay, it's just a faint buzz. Oh, by the way, you can select either Fahrenheit. So 450 degrees Celsius is almost 900 degrees Fahrenheit, by the way. And you can set the temperature with these two buttons. Yeah, and you can go quickly if you keep them pressed in. And you can go by the degree if you press the button repeatedly. Okay, there you go. Is it responsive? I would say, well, when you switch it on, it takes, I'd say a full minute to get up to the temperature you selected. Okay, obviously the higher the temperature, the longer it will take to get there, but yeah, let's say about a minute or so. Once it's at the right temperature, when you use it, the temperature never drops by more than 3 or 4 degrees. So the base unit actually manages to track the desired temperature rather well. And now that I built in a fan control and I placed the cradle for the gun on the left side, yeah, it is, I would say, as perfect as I can make it. Yeah? Now it's incredibly practical and quiet. I don't think you can even hear the buzzing now. Wait, let me put the camera close up so you can experience it yourself. That's about as loud as it gets now with the fan going. Okay, so obviously when I fire the gun, it is louder. Okay, so it is louder when the pump is going, but when I'm not using it, it's quiet. It's really quiet. So, is it a good station? Well, if I were to rate it in its original state, I would say yes, but I would give it a score of, let's say, 6.5, 7. Okay, because of those few things that I had to modify actually in this unit. So is it cheap in use? I would say yes. If you use it on an infrequent basis like I do, then it is cheap in use. The only thing you need to replace now and then are the filters, so the felt filter in the gun itself and the filter in the base unit right here. That's about all where costs are concerned. The tip on the gun is still the original one 5 years later, and it still functions. And the tip itself, let me show you. Yeah, the tip itself is still in very good condition after 5 years of use. Okay, so all it takes is a little bit of maintenance. Okay, so once the tip is hot, you have this little poker you get with the desoldering gun, and it's just a matter of poking it into the tip, okay, like this, and then giving it a few passes like that, and there you go. And that will clean out the tip on the inside. And for cleaning the tip on the outside, normally they provide you with a little sponge, which you should, which you could moisten with some water. Okay, so denaturized water. Okay, so distilled water, in fact. But I prefer to use a brass brush, okay, like this. And I like to give the gun, when it's hot, mind you, a good rub with a brass brush like this, okay. And that way you keep the tip in perfect condition. Yeah, believe me, I've been doing this for 5 years now, and as you can tell, the thing still functions perfectly. So there you go. I would give it, with the modifications I made, a score, let's say, of 8.5. Yeah, with the mods I made. Price wise, well, yeah, it's reasonably priced. I think 5 years ago I paid, I think, 115 bucks or something for it, transport included. And yeah, like I said, it works really well. So there you go. Would I advise this desoldering gun? Well, if you're looking for, let's say, a cheap, simple desoldering gun to be used infrequently, so not every day on an industrial scale, then yes, I would say it's certainly worth its money. If, however, you plan to do some industrial scale desoldering, then no, then I would go look for a far more solidly built desoldering gun, a really professional one, but obviously that will cost a lot more. It is, I believe, a good present to give to an aspiring electronics hobbyist or student. Okay, so there you go. By the way, I'm not sponsored at all. This desoldering gun I paid for with my own money. The maker or the producer of these soldering guns, so in this case Duratool, did not sponsor me. This is really my own desoldering gun I bought 5 years ago. So there you go. I hope you enjoyed watching the video, and I'll see you all soon for another video on my channel. Thanks for watching.